So in this video, I want to show you how we can solve efficiently two linear systems at once. So here's the example. I've got two linear systems, but you'll notice there's actually something special about those two linear systems. That's why we're going to have this very efficient method for solving both of them at once. But let's first start with the first one. If I write its augmented matrix, it will look like this. This is the coefficient matrix is 1, 2, 3, 2, 5, 3, and 1, 0, 8. And the constant part is 4, 5, 9. If I do the same on this side, I will get 1, 2, 3, 2, 5, 3, and 1, 0, 8. And the constant part is 1, 6, minus 6. So what's similar between these two linear systems? It's because it's the fact that their coefficient matrix is the same. So what I'm going to show you works if I have the same coefficient matrix. So if I would just solve the first one, right, I'd probably perform some sort of Gaussian elimination, okay, and eventually maybe recover my my solution if there's one. And over here, I do the same, right? I do Gaussian elimination. So in both cases, I'd be doing row operations. But notice that the row operations that I'll do, they'll be based only on the coefficient matrix. They will be based on the entries of that coefficient matrix and not on the entries that are in my last column, which represents just the constants. So in fact, it's the same steps here that I'd be doing. Same steps, so same row operations. So instead of doing the same work twice, we're just going to do it once and put everything in one big matrix. So instead of having to the right only one constant vectors, I'll put the two constant vectors here. And then I will do Gaussian elimination to that bigger, it's a bigger augmented matrix. It has one extra column now. So let's do this. So what I've done is I've taken my matrix and I've applied Gauss-Jordan. I could have applied Gaussian elimination only, but I did Gauss-Jordan. So you can look at all my steps. Okay. What's important is that I get this in the end. Okay. Now you have to remember that this is the reduced row echelon form of my augmented matrix, and now I can recover my solutions. I have two systems to solve, so I'm going to look at maybe the first one here. Okay, if I look at this one, what does that tell me? It tells me that for the first system, x1 is 1, x2 is 0, and x3 is 1. So essentially, this column gives me the first solution, well, the solution of my first system. And this column will give me the solution of my second system. And the moral of the story is that I didn't have to do Gaussian elimination twice. Okay, so I've got how should I? Yeah, sorry. So the solution of the first system is here. Solution of the second system is here, and I'm done. So you may wonder, well, when is that going to happen? That I'll have two systems and same on top of this, the same coefficients. Well, you'll see that it will happen when we will want to calculate the inverse of a matrix. So that's coming up. Okay, stay tuned.